Hey, what's up guys, my name is Cherno. Welcome back to my code review series, a series in which you guys send me your projects and I take a look at them. Goodbye edition. If you don't know why, it's because I made a goodbye video, but I'm still here. Sorry. Today we have Bennett sending in a C++ chess engine using Walnut for rendering. Thank you for all the hard work you have and continue to put into creating high quality education content about C++. In high school last year, I decided I wanted to learn C++, so I started working on a chess engine. I actually think that's quite a good project idea, a chess engine. That kind of involves everything that like a game would, but there's a lot of algorithms that you can really dive into. So I think it's really good actually for learning C++. The thing with these algorithms and the thing with C++, I think specifically, because it encourages a much more lower level way of programming, the way that you implement a certain algorithm can be done from like a scale of 1 to 10. Like you could do a very naive, low performing solution. You could do something a little bit better. Maybe the memory is just ordered better and the access is a lot more thought about. But then you could go like the next level deeper and even do something like SIMD. So the range of ways that you could implement an algorithm, and especially the types of algorithms that you would find in chess engines, is just like this whole range of levels. So I'm definitely interested to see if there's some cool stuff that's been done here, considering this can generate 40 million moves per second. I don't know if that's high. It sounds high in the move generator and can destroy me. I'm pretty bad though. I mean, you'd expect a chess engine to destroy you, probably. This was one of my first projects in C++. I know you don't like fixing people's broken builds code, so I've made sure it compiles good and runs out of the box on both my desktop and laptop, which use 2 different GPU manufacturers. I mean, it's chess. Like, I know it's Walnut, and, you know, I made Walnut, so there's probably like lots of GPU compatibility issues there, but you would think that rendering a chessboard is something that's totally achievable. I'd love any feedback or roasting you may have of the code I wrote. I even put images and build instructions in README. Yeah, see, this right here. This right here is where it's at. Okay, cool. So we have a link to the repository. I'll leave this in the description below for you guys to check out as well. And I mean, look at that beautiful pawn. That sounded a bit sus. Chess engine and GUI written in C++20. We got this like center aligned links over here, like a menu. This is like a website inside of README, man. Either this guy went hard or this is AI. It's hard to tell these days. Okay, so we got this chessboard rendering here. We got some IMGUI UI, which looks like the Walnut / Hazel theme. We got a bunch of features. Oh, there is SIMD evaluation using SSE intrinsics. Cool. Transposition table with Zobrist hashing. This is like a lot of stuff that if you guys are interested in, you can look up, because these are sort of more or less chess specific, I mean, or chess-like game specific algorithms and ways to do things. All of this looks pretty standard. Really good that there's an actual getting started with prerequisites and building. This is really important to have in pretty much any GitHub repository where you have a project that you want other people to be able to, you know, actually have a look at. Click or drag pieces to move. Okay, cool. So we'll just play chess. That's the plan for today's video. We're just gonna play a game of chess because we like have to test this, right? So yeah. In fact, while we're on the topic of testing, one thing that is coming to mind here is, are there any tests? Because no like unit tests or any form of testing at all has been mentioned. And the thing with chess and all of these algorithms is they like really do need testing, because if there are subtle issues with them, then that's gonna screw everything up. So because this does use Walnut, and Walnut does have like a headless build, I wonder if there are any attempts to use that to just like run tests, basically. I have kind of a love-hate relationship with unit tests. I mean, it's mostly hate, but that's because I work on game engines, and game engines like don't, I mean, a lot of areas of game engines do work well with unit tests, but game engines as a whole don't really lend themselves well to unit tests. I mean, a lot of areas and a lot of specific systems of game engines do, definitely, but game engines as a whole need a much deeper and different, usually custom testing strategy. But when you have specific areas like this, which is like the core, the heart of how all of this works, like that really does need that. And I think Walnut's kind of a nice choice because you just have this easy headless build and you could just deploy lots of various different creative ways to test this. So we'll have a look to see if the code has any consideration for that, and maybe it is set up for that kind of stuff. We'll have a look. Now, if you're sitting here being like, cool, this is written in C++20, but it would be even better if it was written in Rust, leave a comment below if that's you. And if that is you, or you think it could be you should check out Let's Get Rusty, the sponsor of this video, and learn Rust. If you're a C++ developer, you've probably heard of Rust. And if you're like me, you've probably been putting off giving it a go and learning it. Well, that could end today, because Let's Get Rusty focuses specifically on Rust education and job-ready training. It's also made by a fellow YouTuber who has this YouTube channel all about Rust. Rust sits in a really interesting space. It's got all of this low-level control and performance that you're probably used to if you're coming from a language like C or C++, but with modern tooling, with strong safety guarantees and built-in support for fearless concurrency. That combination is exactly why companies like Google, Microsoft, and Amazon are adopting it more and more in production. It also keeps topping Stack Overflow's most admired language year after year. Let's Get Rusty runs structured programs for individuals and teams, and they've helped thousands of developers over the years actually get productive with Rust, not just watch tutorials and forget everything a week later. And here's the good news. They're actually running a new cohort next month, and spots are limited, so now's a really good time to check it out. Go to letsgetrusty.com/start with Cherno, link will be in the description below to find out more about their training. Huge thank you to Let's Get Rusty for sponsoring this video. One more thing I want to mention about this README, by the way, is I called someone out before for having one of these because I was like, there is no way a human did this, and there's no way that a human really needs to do this. So this is now kind of raising the bar of AI suspicion. I don't know, like, if this is really that necessary to include in a README. I mean, it clearly doesn't scale well because as you start adding more files, are you always updating this? Every time you add a new file, you're like popping it in here. I mean, look, there are so many things here, like bindings.cpp. I guess that doesn't have a header file, so maybe it's not here because it's not public or something. Perft.h. It's not here. Serial communication.h. I don't know what that is, by the way. It sounds scary. That's not here either. So this is what I mean. Like, I don't know. Sounds silly, but what do you guys think of this? All right, whatever. I don't have time for this. Let's get into the code. So here we have the engine checked out. Because they said they were so certain that it would just build and run, I actually want to test this live. Now, inside vendor bin pre-make Windows, there is an executable binary which I have replaced with my own because I'm not taking any chances. That, I believe, is the only executable file that actually shipped with this. So now that I have my own pre-make, let's go ahead and have a look quickly at what this batch file does. Vulkan SDK. Okay, that's bold. I've never seen anyone download and install Vulkan SDK in a batch file. I mean, I guess why not? But like, I don't know. I'd probably use, I mean, they're not using CMake, so they can't use all of that stuff, but I'd probably use like Python or something a bit more serious for that. And then we run pre-make. Okay, well, I do have Vulkan SDK, so if I run this, then hopefully it will just work. Wow, that was really quick. I feel like that finished before the actual command prompt window finished opening. Okay, and then we have a solution file. So, I mean, this part seemed to work, which is good. Gonna go ahead and drag in the output window, get rid of this, and then we'll do a release. Oh, there's even a dist. Yeah, that'll be from Walnut. We'll just do a release build and we'll see if this works. Okay, that did in fact succeed. Let's go ahead and run it. All right, awesome. Oh, this is cool. It's using like the non-decorated window. Let's go ahead and minimize everything so that this looks nice and pretty. And then I guess we can just play. So there's a time limit of 1 second for the AI to think. So do we just click and drag? This is cool. It brings up the little preview. Do I have to press this? Oh, AI color black. Okay, cool. So I guess we just play a game of chess to test this. Resizing works. I'm getting more distracted with actually playing with the app. But resizing works. That's nice. Like, as in it makes the board bigger and everything looks very crisp. So that's nice. I'm guessing you can just drag out these panels as well because it's all just like I'm GUI and Walnut. Okay, I must confess I haven't played chess in a while. So probably should. Okay, I think I have to take, and then we're going to lose our queens. Oh, he didn't take my queen. Protecting his queen. Okay, let's just castle. Guess that works. That's nice. Okay, cool. So game definitely works. Really nice. I think the only thing that I found that was missing was just the pieces that have been captured. But other than that, I think pretty cool. And there's obviously no sort of game over or checkmate indicator, so that would be good, or a check indicator for that matter. Okay, so first of all, as we dive into this code, I'm trying to find so we have game.h, but we don't have a game CPP. I'm wondering where the entry point is. Let's have a look at this file. So we have a game layer, so that's got to get added to, yeah, everything's implemented inside the header file, which is a bit weird. There's a lot of commented out code as well, but why is there no game CPP? That is interesting. But anyway, game layer has got to get added. So in Gambit app, did I see Gambit app? Yeah, Gambit app, of course, that would be the main. So what happens with Walnut is that there is an entry point over here that gets included. So you can see in the entry point header file, which is what this is, we basically end up with either this WinMain or this normal standard main, depending on if it's like a distributed Windows app that doesn't have a console, then it would land here. Otherwise, it would just be the normal C++ main. So that gets included here. And then create application is ultimately what would get called from here. So this is the main function you can see that's being called from here. That creates the application. That immediately runs some Win32 API code, right? So this is from Windows.h and will not work on any other platform. So that's another thing that I should have mentioned was I'm always interested when I get code to see if this would work on different platforms. And at this point, obviously not, which is fine. Like it's okay to make something specifically for Windows or for a specific platform. But if you are trying to write better code, then what I would do is make sure that anything that is platform specific is in its own sort of platform specific CPP files, or at least behind some sort of if def, kind of like we do actually over here in Walnut. I mean, we do this because we also want to make sure we don't do it for headless and only for disk builds, but you can see that like if defined WL platform Windows. So it's really not hard to add that to this. Like you could literally just do something like that. Now, technically speaking, you probably want to have potentially the equivalent for other platforms. I don't really know what that would be. And so in that case, you would have some sort of set process DPI awareness or whatever function inside your actual API that would then potentially be implemented in a different file or in a series of different files that only get compiled for the platforms they are meant to be compiled on. That avoids polluting this create application function with all of this random stuff that we don't really care about. Okay, so this is just some Walnut app specification initialization stuff. This is where we actually push that main layer, which is our game layer. Look, there is an if defined headless, and then we just do this UCI loop. Right, so this is where that whole UCI thing comes in. UCI, by the way, in this case is the Universal Chess Interface, and it just lets us write stuff like this. So it's sort of like a command line interface, we'll say. So that must be what's being tested over here. But since you are clearly aware of headless, and by the way, there is like a WL headless defined already for Walnut headless, but since you are aware of headless, this would be a really good opportunity to actually test some things. Speaking of which, game layer has a whole bunch of stuff in it that I can see is not really UI specific. So all of these like move generators, bit boards. Okay, cool. So yeah, we looked at a chess engine a while ago. It was doing a similar thing. So this is quite a popular thing to do. But anyway, all of this stuff that is clearly very calculation oriented, this is like the actual brain of what's going on, is tied directly into game layer. So I wouldn't do it that way. Game layer is a Walnut layer, which is a way to control what your application actually does. And it's also a way to control the UI and render everything. But the core issue here is that the way that the game is actually played is all sort of within here. Here's also another Win32 thing. Serial handle. So serial, I really wonder what that was for. We'll check that out in a minute. So the way that I would structure this, I mean, first and foremost, I would definitely make that game.cpp file. But anyway, the way that I would structure this is in a way where the AI isn't just sort of intertwined with the logic of what's actually being calculated and what's happening. So I would just clearly separate the chess engine part of this and the UI rendering part of this. Now, speaking of which though, I'm sure that all of the chess engine stuff is not being calculated on the main thread, especially because I can see the word async in various places. So we have this async AI search result, searcher async result. So I'm guessing this is gonna search for different moves. So here's the best move, and here's whether or not it was completed, and there it is, find best move async. So where is this called from? So we call this from game.h. So AI turn, so when it's the AI's turn, I'm guessing, and then there's a true or false for color. Okay, so I would also make this like a little enum or something, so that there's not just like bool color, because what on earth is, like, what color is black? What color is white? I'm assuming black is false, which, you know, because like black is 0 in color and white is 1. So if it's white turns and is white AI, then yes, AI turn true, otherwise AI turn false. But yeah, like again, it would just make more sense if it was like black or white instead of true and false, especially because there's no like, obviously there's no runtime difference. It's just for developers to be able to see. I would definitely drop this onto another line as well. We've got this lerp timer. Is this like, what is this for? Animation length. So see, this is what I mean. Like inside us trying to figure out an AI move, we are also like calculating the best move, but then also doing animation stuff. So this is what I mean. That should be separated. And then play move will, yeah, just do board make move, which will update the board state. Game history. Okay, there's a game history as well. Yeah, we saw those like arrows, I guess, that let you move throughout the game's history, which is cool. And then yeah, here is the async. So I'm guessing this, because it's checking for whether or not the async AI search result is completed. So I'm guessing we just run this like every frame. Yeah, it's inside on update. So basically if it's White's turn, for example, and the White is the AI, is just going to keep going through this AI turn again and again. Sorry, I'm just fixing all this code with my opinion. So we're just going through this again and again, and we're basically just waiting for that AI to have completed its searching for the best move calculation. Then we grab that best move, which, okay, we have some force inline stuff. Again, MSVC specific. This stuff should be, if you really want to force inline, do people still do that these days? To be honest, I'm not 100% sure. But anyway, I would just make a macro that, you know, is this on Windows and whatever else on other compilers and other platforms. I guess not specifically Windows, it's just specifically MSVC. Okay, and then we have a move being all of this stuff, sure. Okay, so we find the best move and then we reset the move. Okay, so there's some like, it's a shared pointer, I guess. And there is some communication between threads here, but I guess it'd probably be okay because we're waiting until this is completed before we do anything with it. And I'm assuming we can't kick off, or we're not kicking off another move that might write into here until that's done. Yeah, I think a lot of this is kind of gray area stuff because, for example, we're pushing the board state by reference and then we're copying from it on this job thread. Now, would it be modified by the main thread? Well, probably not. I mean, the player is not really going to make moves while the AI is thinking, and that's also something that we could just not allow regardless. If that was the case, then that would be a little bit dodgy because it's like we have our board state over here, and then we have this job thread that's kind of reading from it at the same time as some other thread might be writing to it, and we have this weird condition where it's not atomic, it's not locked, it's not copied, it's not double buffered, so that's technically wrong. However, if you sort of orchestrate these rules, how it's like, okay, but I'm not going to do that, then technically it's okay. But in my experience, in the long term, like code is code, and you might a year down the track decide to introduce some feature where, oh, actually I can now do this, and you don't really remember these rules that you've set for yourself as to how we should be synchronizing this data access, because there's nothing in the actual code that's preventing you or making sure that you do it the correct way. And I'm just using this as an example because this is one of those things where it's like, okay, why are we running this on a different thread? Because we don't want to block the UI. We still want to keep updating the UI. Why do we want to keep updating the UI? It's probably not 100% necessary, but what if like the user wants to go through the history of moves, right? We might give the computer some more time to think than 1 second, and maybe we still want to keep our UI responsive. We don't want to just completely freeze the main thread. But we know that nothing else is going to be happening in the actual game board. No one's going to be moving all of these chess pieces. So therefore, it's not really concurrent, is it? Because even though we have this job thread over here, let's just say, and then we have the main thread over here, what's happening is that the main thread is modifying the board, right? Because we've made some sort of move. And this, by the way, is time kind of going forward. So we're going to be modifying the board because we made a move. And then the AI is going to be, so this is me. This is the AI. The AI is going to be modifying the board, right? And that's not going to happen at the same time. And then when the AI is done, I'm going to be modifying the board. So even though we have this like situation where this is in fact happening on 2 different threads, there's no way that this could like move up into this territory where it's suddenly like, okay, yeah, that's bad. We're doing this at the same time and no one's kind of controlling the access to that. So it is still done in serial. It's not done concurrently. However, it is 2 different threads. So yeah, this is something that I call a gray area. And my gut feeling is always to be like, okay, but we do have these 2 threads. So let me just synchronize that. Let me just make sure that I'm copying the data or double buffering, and I have something in place that makes sure that there's no possible race conditions or anything that could go wrong here. Honestly though, I'm interested in what you guys think. So leave a comment below if you have any opinions on this, but this is definitely the kinds of things that you should be thinking about when you're working with stuff like this. Okay, since we're in this search file, let's have a look. So we have search logs, which is just turned on. Right. Okay. So this is something that we probably shouldn't just have persistently on. Usually with logging and, you know, writing all this stuff to files, you probably want to maybe use that for development, but not for distribution. I don't know, I might be wrong. Like, you might want to keep logs for distribution. That's also totally fine. A lot of logging is required, but maybe not as much logging or something, because obviously logging is also a performance consideration. So this is something that I probably would not just arbitrarily define, you know, in this header file, but rather I'd have it as like maybe configuration dependent, or some sort of level of it would be allowed in like debug and release, but maybe not distribution. Main thread running store false. So this is an atomic bool. So we are specifically setting this to false from the searcher. I'm guessing this is all running on the main thread, except for that one thing that creates a job. Actually, we were looking at that job stuff. Let me just have a look. So this locks the mutex and pushes it to this job queue. So I'm wondering where that actually gets consumed. So main thread search function. So while searcher main thread running. So this is the searcher's main thread. Why is it? I don't really understand what thread this is running on. Okay, so if you guys are like me, like I just said, and you don't understand what threads, what thread something is running on, then all you have to do is put a breakpoint in here. Hopefully this will compile, because I seem to have made a modification. And you can see that it is in fact not running on the main thread. So we have this like UCRT base .dll thread. By the way, really good idea to just name your threads. I would highly recommend you do that. But another thing you can do is debug windows and parallel stacks, which is over here. So if you open this window, let's make some more room here. So this is a really nice window that I should probably make a video about because it's great. This shows you all of the running threads that you have. So ignore there's like some external stuff running as well, but ignore that stuff. These are the two main threads that we have at the moment. So we have the main thread, which you can see this is our actual main function. It came through here, and at the moment it's initializing the log. And then we have this searcher main search thread function, which is just doing this as well. So if we just run this for a bit, and let's set this to black again, and then let's do that, and then let's actually just make it play its own game, and then I'm gonna hit the pause button up here, and then we can have a look back at parallel stacks to see what's going on. And you can see we have a whole bunch of different threads here. A lot of them are completely irrelevant, but if we have a look at the ones we've got, so we've got some searcher, this is our code clearly that's going on over here, so we can see that. We can see there's some condition variables that are being waited for from this main search thread function as well. Here's our main function. So yeah, parallel stacks can definitely be very useful for trying to make sense of what exactly is going on. So this is in fact running on a separate thread. I'm guessing we'll find that over here as well. This is probably a fairly good use case for a lock-free queue, so feel free to investigate that as well. Definitely not a big deal, just something that might interest you. And so we're basically waiting for this queue condition that's going to get signaled as soon as we actually push something onto the queue. So this is kind of cool as well. And then once we do receive that signal, so we're basically just sleeping this thread until we actually get some data, some sort of job to take care of, and then we grab that job and we run it on this thread, which is pretty cool. I think that's definitely a fine and pretty straightforward system. So this queue condition variable, which we're waiting for on this search thread function, only gets notified once here. I can't find any other notifies. And so what could happen when this gets shut down, I don't really, like, we could just be waiting. We could just be waiting on this thread to be notified, and that notification never comes. And so this kind of just hangs. So I think on shutdown, we probably should just do like a notify all or something to make sure that this gets unlocked, because otherwise we'll just be waiting. We'll just be waiting, and that's kind of it. That's a bit sad. And by the way, again, why is this in a header file? Why is this not in a CPP file? It's just so weird. Like, what was your rationale for putting some of this stuff into CPP files and some of this not, like, just in header files? Very, very interesting. Okay, here's some nice juicy numbers. These are just some random numbers apparently that I guess are probably part of this Zobrist hash thing. So Zobrist hashing, or Zobrist hashing, is a hash function used to implement transposition tables, which can be indexed by board positions and used to avoid analyzing the same position more than once. This serial communication header is really quite interesting. I wonder if this was like meant to, yeah, hook up to some hardware or something, but it's never used. It's only used inside here, but it's commented out, and then write data as well is in commented out blocks. We've got some bonus tables for each piece inside evaluation.h, as well as a lot of SIMD stuff as well. So this takes in the bit board and a table. I wonder how this is used. Yeah, right. Okay. So it's just going to compute the sum of all of the bonuses that we get for each piece. And that, of course, is used to evaluate how good a specific position is. Cool. Overall, yeah, really nice project. It's that range that I was talking about. There's like levels of like, you know, there's so much room here to grow, I guess, as an engineer, or just to try out some cool things like the SIMD to sum up the bonuses that we're doing over here, various different ways to implement all of this search stuff and multi-threading. I think it's a really cool problem to solve, making a chess engine, and it definitely touches like a lot of different aspects of programming, C++, and computer science in general. In summary, in terms of actual code, I would just say, I mean, number one, stop implementing everything in header files. I don't know why that's being done. Put stuff into CPP files, otherwise you have to recompile everything, and also it just keeps it more organized. I would also separate out the way that the main game runs from this game layer so that it's not as tied to UI. And speaking of which, this is a really good opportunity to run some tests, maybe in like a headless configuration, so that you can actually make sure that all of these advanced algorithms and computational things actually run correctly. I think doing stuff on this level of like computational and algorithmic complexity without having unit tests to make sure that stuff works is just madness. And finally, the threading. Yeah, the threading is generally okay, but I think that maybe you could be a little bit more explicit about how certain things are done, and that how that data is sort of shared between threads, and maybe have a few more safeguards in place. If you guys enjoyed this video, please don't forget to hit the like button. Let me know your thoughts on this project as well in the comment section below. If you want me to take a look at your project, send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you all for watching. Don't forget to check out Let's Get Rusty in the description below, and I will see you next time. Goodbye.